Hi, welcome everyone to our very first lecture of learning programming fundamentals using Java language. My name is Aqib Javed. Before starting, let me just give you a very brief introduction about myself. So currently I'm working as software development engineer in Amazon and located in Cambridge, UK. I'm the part of their AWS team and working in their S3 service, where we are responsible to deliver durable, resilient, fault tolerant and scalable event notification configured in your S3 buckets. I have overall 7+ years of experience working in different domains, including e-commerce, finance, banking, game development, management system, payment card industry, IoT, CMS, data analytics, investment bank and service provider. I'm also a Java certified developer. I have done my Oracle certified associate back in 2018 using Java 8. Okay, just to give you a very brief overview and introduction that what we are going to learn in this complete course is basically we're going to see our programming fundamentals using Java, typically targeting all of the latest version, afterwards Java 8. We will see our fundamentals and very basic programming structures and constraints using Java language. We will also have a look on Java memory management and allocation by having a brief introduction of garbage collection towards its advanced mechanism of doing garbage collections and tuning. Beside that infrastructure level of things, we will also have a look on object-oriented programming, and we will touch all of these 4 object-oriented programming pillars, which include encapsulation, inheritance, polymorphism and abstraction, and we will construct using these concepts by our real-time examples. We will also have a look on the casting and boxing, how it works in Java, what does that mean there in Java. Then we will go in detail of data structures and generics. We will do some hands-on experience with data structures. Also, we'll try to solve some of the algorithms which are quite popular in industry. Then we will look into this IOStreams and exceptional handling. We will see that how effectively we overcome to errors and exception in Java. Then we will have a look on the stream APIs and functional programming using Java 8. Then we will cover multi-threading and concurrency, and then at the last of our session we will have a look on socket programming. If you guys want to in the contact with me and you want to connect me, then these are some useful links. I'm available on LinkedIn. This is my GitHub as well, and you can read some of articles which I wrote on my Medium channel as well. Beside that, I also spent some time of writing articles on my LinkedIn as well, so you can just have a look there. Before starting our very first lecture, where I will going to show you a complete hands-on and practical work to how to install our JDKs and the libraries which we require to run our Java application, and which IDE which we are going to use. So IDE is basically a software which developers use to write code, and it helps developers to compile, debug, and then run your particular application into your system. So before going to that, before just looking into this thing, I want to give you a very brief introduction, like how Java came into existence, what is the background of Java, and what is actually Java. So Java is basically a high-level class-based object-oriented programming language. So when we call a language which is object-oriented programming language, then it's mean that when we have to write our code, then we have to write starting with the class. So we follow a class pattern, then we write our main method, and then we start writing our code. So this is basically a class-based object-oriented programming language. Beside that, this is very interesting thing. Like, people usually think that Java is a pure object-oriented programming language, which is not 100% true, because Java still support primitive data types. I will going to explain all of these details into our next sessions, but just to give you an overhead that Java is a OOP language, but it's not pure like Ruby. So Java is basically designed to have a very few implementation and dependencies possible, and then write your code and just get the outcome there. Its general purpose programming language is basically intended to make our developers enable or to capable of writing your code once and run it anywhere. So what does that mean is basically Java will help me to write my code here on Mac, and the same code I can run on Linux and Windows without changing my code. And how that magic happened is we're going to see that into our JVM implementation. One more attribute of Java is basically performing memory management for us. So we don't need to worry about it. We don't need to create an object and then deallocate an object and then clean that object from memory, just like other languages like C and assembly. But Java is taking care of that for us. And how Java did that, because in JVM, I will explain that what is JVM, but in this is a particular component called JVM, which is stand for Java Virtual Machine, which help us to run our code. It have another software that is called garbage collector, and garbage collector is basically responsible of removing all of unused resources from your memory. So what happened back in June 1991 is basically Sir James Gosling was initiated this Java programming language under the company name Sun Microsystem, initially named as Oak. So Oak was a tree which was in front of their office, so they decided to name that language Oak. And the intention of that language is developed for interactive televisions and digital television. But language was for digital television industry that time, so they decided to launch it as a standalone language. Oak project renamed to Green, which was the name of which was basically the name of the team who was developing that language, and finally renamed to Java, inspired by Java Coffee from Indonesia. 1.0 version was shipped in 1996, which support applets as well. So during that time, the running an application on the website is like a bit of tricky part, and then Java introduced that applets which support your sort of service or dynamic sort of implementation of an application inside your web pages. And that after like 2 years they release another version which is also called Java 2 standard edition, with a lot of configurations, multiple configurations built for different platform using J2EE and J2ME, which was some of the two more edition basically comes up with Java. And they was also introduced in 1.2. Just to mention here that each of Java version was released after 2 years gap, except of 1.7, which was released after 5 years of gap with huge changes. And then 8 was released basically in 2014, almost 4 years later, after 3 to 4 years later after 1.7, and it was a deal breaker. So they introduced a lot of things in that. They introduced Lambda, they introduced functional programming and stream APIs, which we're going to discuss in our sessions. And right after 1.8, more or less all of the versions are basically coming after 6 months, and the latest one is basically 18 right now. Okay, just to give you an idea about all of the terminologies which I was using, like JDK, JRE and JVM, let me just give you a very abstract level of introduction about those. So JDK basically is considered that it's basically a box which gives me, because I'm a developer, I want to write code in Java and want to develop something, and that box basically going to provide me some tools to help me out to write my code, run my code, compile my code, and ultimately deliver that code to your machine so that it can be executed. So I don't need to worry about those things. JVM comes up, Java basically they provide us now a JDK, Java Development Kit, and that kit basically contain all of these tools. As I earlier mentioned, that Java was initially developed under a team within a company named Sun Microsystem, and around 2006 or 7 it was acquired by Oracle, and this JDK basically provide us by Oracle, and they give you all of the tools into this single box, and you just need to install that. You just need to all you just need to do is basically to install it, run it on your system, and that's it. You will have all of the tools, and then you have to just install your IDE and start writing code. So it's like, for us it's very easy to just start writing code, forget about worrying about all of these infrastructure and the tooling things. JDK will take care of that. JDK, the box itself, have another box inside it which is called JRE, that's called Java runtime environment. So JDK basically have compiler, your application launcher, applet viewer, and then basically with all of these things is come up with JRE, Java runtime environment, which include all runtime utilities required to run your Java application. So when you are writing your code, you require some of the existing utilities, runtime utilities, which you need to run your code. Maybe if you want to write a code where you want to print hello world on your console, then maybe for this particular purpose you need some of the system libraries to perform these actions, and those are basically comes with this JRE structure. And JRE also provide us a very important component which required us to run our application, and that is called actually not only run but also like convert your application to the machine code, and that is called JVM. And JVM basically comes inside JRE. And JVM, as I mentioned, like it stands for Java Virtual Machine, and JVM basically consists on two further components. One is called just-in-time compiler and other is called interpreter, which basically convert your code, read your code, convert those into your machine language. So JVM directly does not read your code. So what happened is when you write your code, it basically goes to your compiler, Java C compiler, which is written in standard C language, and that Java C compiler convert your code into an intermediate language that is called bytecode, and those bytecode basically forward to your JVM, and then JVM read those bytecode. JVM itself have another compiler that is called just-in-time compiler. We in short form we call it JIT compiler, and there is another component in that JVM that is called interpreter. So interpreter and JIT compiler both read our bytecodes and convert into machine language, and then execution basically happen into your system. So that is basically an abstract level of role of your JVM and JRE and JDK. And we will see in our next lecture, like in more detail, how JVM works. So that's it all for this lecture. I hope you like it, and please follow me for further lectures, and we will try to do some practical hands-on. Thank you so much.